just to show you that it's a closed system. Okay? A closed system. So we start off with our packaging material here. So this is called a packaging material reel, not a roll, reel, RWL. Packaging material reel on paper, packaging material. Then from the packaging material reel, then we go to the peroxide bath. So here, once we enter the peroxide bath and go out of the peroxide bath, this is the sterilization process here. Okay? 4 to 6 seconds, 82 degrees centigrade. We sterilize the packing material. Then out of the packing material, then we come through the drying chamber, air knife, and we form a tube, a tight tube, and make a seal here. So now we say that the aseptic chamber and drying chamber is closed. Now the sterile air system is closed by pulling a tight tube. Okay? System is closed. Peroxide bath is used to sterilize material, and the peroxide bath is fed from a peroxide tank. And we heat up the peroxide indirectly by a water heater. Okay? We do not heat the peroxide directly. It's by water heater. So, the closed system, how does it work? From the aseptic chamber, drying chamber, here, we drag air out of the aseptic chamber. Then we bring it down into a compressor. Okay? Into a compressor. The compressor is a water ring compressor. Water ring compressor. We need water in the water ring compressor to make a seal. To make a seal in the compressor to create a pressure in the water ring compressor. I'll show you some diagrams of how we do all this, okay? But this is just a basic overview of the closed system. So then the compressor, together with water, creates a pressure, and then this water, this air pressure then is fed into a superheater. So the superheater here heats up in sterilization to 400 degrees, and the production 360 degrees. The purpose of the superheater is to kill any airborne bacteria. So we heat up the air and we kill any airborne bacteria. So the purpose of the superheater. From the superheater then, it will go through a series of valves and heat exchanger and so on. But basically, it just goes back into the septic chamber, hot air. The hot air then creates an overpressure inside the aseptic chamber, and then we drag the air back out, and we go back in again. So the air will go into the aseptic chamber, and some will go to the air knife. So we have this closed system, okay? Closed system. So this is basic, just to give you an idea of closed system. Also on your machine for the speed, you have UV lamp to destroy any DNA of the microorganisms that are left on the packing material, because we don't have enough holding time here in the tank. Okay? Basic overview. So think of this basic overview. But I'm just going to take you a little bit more forward. To here. Okay, think about the basic overview. Okay, basic overview. Remember in the basic overview, we drag air from the aseptic chamber, drying chamber, here. So air out through the flow meter, down to the scrubber. I'll explain this in more detail later. Okay, I just wanted to show you the closed system. Into the scrubber, scrubber to the compressor, compressor to water separator via the heat exchanger valve, or heat exchanger, depending on what step we're in the machine. then into the superheater, then out of the superheater to the preheating valve, the preheating valve, then through the B valve, down the filling pipe, and into the aseptic chamber, and into the air knife. So our closed system, if we're looking at this, is from here, down, through. It could go this way, or we can go this way, into the superheater, then pipe out, whole pipe, back out, to here, to here, and then to here, to here, and then back out again. So this is our closed, a bit more bends and twists and turns, but this now becomes the closed system, okay? So when we're going to be talking about sterile air system, you think about the basic closed system and think about the normal closed system, how it's being, the air is being regenerated all the time. What we have just here is a little valve, just here, because we can't always suck from the system completely, because we create a vacuum. Okay? So we have this little valve here. We call this the reference point valve. And this just is a flipper valve. Plop, 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 plop here. So it gives more air in to the system, so we don't create this vacuum. Okay?
So, boy, that goes straight into the aseptic chamber.
Yeah.
Is there clean air going in?
No, it's not this. From here. But this air here goes this way. You can't go back in over here. Because here we have this.
I see the baffle in there.
Yeah. Okay. This is called sax valve. Yeah.
Yeah, you know sexy.
This is very sexy. So the air coming in here will then get
straight into the
superheater. Here will kill any airborne bacteria. Okay. So this relief valve here will just allow air in, but it doesn't go into the system. Okay. So that's just to show you, give you an overview of how the system is a closed system. Okay. So now if we go back. Back. Here, then went to here, and now we are here. So this is the sterile air system as it is for A3speed 400 on your machine. Okay, development step 400. So this is as it is, exactly. These diagrams are exactly what the machine is. If you want to see something, you want to blow something up here. Not as in blow it up, but if you want to blow something up, if you want to blow something up, like this, you see how it's quite definite, okay, what is in. So the sensor, the cam, the bearing, the shaft, the spring, the sax valve, okay. If you want, so this is showing just now it's closed, okay. But this one also. This is just an overview, okay. But what you see, what you see in the diagrams is exactly as it is.